To class today, pre-calculus students, on Thursday, the 26th. Hope you guys are doing well. Hope you're finishing up your tests, working hard on your math, and not getting behind. Please stay on top of your math and don't get behind. Please work hard. And if I can help you at all, don't hesitate to contact me. My voice is a little raspy today, so please excuse that. I'll be coughing a lot and clearing my throat and probably drinking some water, but other than that, we will get through this lesson just fine. First of all, you'll have a quiz this weekend. I know that you know that, and I know you're superbly excited about that. So you will have a quiz emailed to you this Friday. I will let your parents know, and I will let them know when it is due. I would like it to be done by Monday. That gives you Saturday and Sunday to work on it. I'm definitely pushing you guys. I will admit that, but I'm not pushing you. I'm trying to be reasonable. For example, Tuesday's video was over an hour long, but you had no homework, none. And then Wednesday's video was just homework. So I do try to be reasonable, but you will have a quiz this weekend, so please make sure you're ready for that. We'll talk more about what's going to be on that quiz on Friday. Keep your integrity sheets updated. Matthew, I don't think I've heard from you. If I have, please forgive me. I know I'm a little forgetful, but I thought you were going to contact me that night, Monday, and let me know, because that was the deadline. So I know you'll be honest with me. I'm not worried about that. If you did not get your sheet done by Monday, then please email to me what you did get done. Let me know so I can give you some grades there for your homework. I really need you to do that, okay? Thank you. But keep your integrity sheets updated, men, okay? So far, you've had one assignment. That was Wednesday, yesterday. Tuesday was notes only. Wednesday was homework. So please make sure you're keeping updated, keeping your integrity sheets updated. Tests are due by Friday. Now, again, I love you all, you know that, but if I've not heard from you by Friday, I'm emailing parents and I'm saying, hey, your son is behind. He needs to get his test done. So you need to let me know. Caleb, you've turned yours in, and Corey got your quiz, so great job on that. But now, excuse me for stuttering, I need 3 tests to be turned in by Friday, so please keep that in mind. And again, I warned you guys. Let me get a drink of water here. I will be doing that a lot throughout the video. Okay, continuing on. We're going to be looking today at 2 different topics. Now go ahead and get your notebooks out, get your textbooks out, get your calculators, get your pencils, whatever else you need for class, and let's have a great class period today. Work hard and let's learn some math. We're going to be looking today at 2 different topics. Now don't worry, I'm going to keep it reasonable, but we are going to be looking at 2 different topics today. Here are the 2 topics. Now, by the way, you do not need to write these down, okay? I'm going to list them for you again later when we get to each individual topic. Now, if you want to write them down, that's your prerogative, but you do not need to. All right, so let's take a look at these topics. And my computer's freezing up. There we go. Airplane word problems. Contain your excitement. Some more word problems. So we're going to start off with that topic. You're actually going to find them really, really easy. And then topic number 2, angular speed word problems. And that's incorrect. I'm not sure why I typed that. That's totally incorrect. That's kind of funny. You love it when I cross off word problems, don't you? Where'd that come from? The other topic, and again, you do not need to write this down unless you want to, is going to be central angles and arc length. Okay, so those are the 2 topics that we'll be looking at today. So without any hesitation, I'm hoping today's lesson will be kind of short. And the homework's pretty short too, by the way, so this might, don't hold me to this, but this might end up being an average to decent easy class period. We'll see here. Hold on one second, please. I'm looking at something. Okay, so here we go. Let's go ahead and start off today looking at airplane word problems. Would you please write that in your notes? The lesson number is 5-3, and if you'd like to be organized with your dates, which I encourage, the date today is the 13th, 9/26/13. Airplane word problems, lesson 5-3. The first thing that you need to realize, students, is how to correctly draw the bearings of an airplane, whether it's traveling north, east, south, west, whatever. If you can't do that, then you will be completely lost right away. Now, it's not difficult to do, students, okay? It's easy, but you still have to be taught how to do this. And you're getting a little navigation education, so it's good for you, all right? Please listen carefully to this comment. Here it is. I would write this down. When dealing with aerial, and by the way, that's spelled correctly. It looks a little weird, but it is. When dealing with aerial navigation, directions are given in degrees clockwise, starting at the positive y-axis. Let me read that again. I would write this down. When dealing with aerial navigation, the directions, or the bearings, whatever you want to call them, are given in degrees, running clockwise, going clockwise, so they're going this direction, clockwise, like a clock would go, starting at the positive y-axis. So here's a coordinate plane. This is the y-axis, and the positive part would be this part up here above the origin, okay? Now, I'm going to explain this a little more later, but you need to write that down. Now, sorry about that. Let me give you an example real quick of what I'm talking about. I would go ahead and write this down in practice, okay? Let's say that I told you an airplane is traveling let's see, in a direction of, I don't know, 280 degrees. There we go. I've given you the direction or the bearings of an airplane, 280 degrees. Now, I want to get a picture of that so I can then do some work with this situation. Now, first of all, draw a coordinate plane. That's the best way to do this. Okay, so go ahead and draw a coordinate plane. And now I'm going to get a picture of the direction this airplane's heading. Now remember what I said here. When dealing with aerial navigation, directions are given in degrees clockwise. So we know we're going to go this direction. And you start at the positive y-axis. So I'm going to start here, and I'm going to rotate clockwise as often as I need to. Now I want to travel 280 degrees. So I start here, like the directions say, start at the positive y-axis right here. I'm going to go to there, that's 90. So I'm going to keep going, that's 180. Keep going, that's 270, and then go 10 more degrees. Now what that means is you stop right there. That's where you stop. That means the airplane, by the way, the origin is always the airport. When you're drawing these types of problems, look at the origin as the airport. That's where the plane's leaving from, okay? And so now the plane's going to take off from here and go like that. Now you see the direction of the airplane, and here's where it took off, and here's how far it's traveled, okay? And so it's going on and on and on this direction until we find out otherwise that it's changed directions, okay? So that's how you deal with a bearing or directions of an airplane. You start the positive y-axis, you go clockwise, just like a clock rotates this way, until you get to where you're supposed to stop at, and then draw your line, okay? So now that you understand that, let's go ahead and try two-word problems, all right? In your notes, I would encourage you to write this down. An airplane leaves an airport and travels for 100 miles in a direction of 300 degrees. How far north of the airport is the plane then at that time? And how far west is it? So how far north and how far west? Are you ready? All right, here we go. First of all, let's go ahead and get a coordinate plane drawn. There we go. And now let's go ahead and draw our bearing. The airplane is flying in a direction of 300 degrees. So I start at the positive y-axis, and I rotate to here. That's 270, and then 30 more degrees. So I rotate, and sorry about that. It's really hard to draw on this thing. And I went around 300 degrees. All right. Now, I've traveled 100 miles. Now, this is the airport, okay? I'm going to go ahead and get rid of this arrow on the end because we've traveled 100 miles. So I'm going to go ahead and sketch this line here. So the airplane took off from here, and it traveled. We're going to say right now the airplane's there, and I'm going to go ahead and put 100 miles because that's what the problem says. The airplane's traveled 100 miles. So I know the length of this line is 100. Let's go over that again. The airplane took off at the airport, and flew in this direction. How did I know that it was flying in this direction? Because it said 300 degrees. So I started at the positive y-axis, I rotated around 300 degrees, and I drew my ray, or my line. And now I put an endpoint right here, and the airplane has flown 100 miles. Now, look at the question. How far north of the airport is the plane? Now, north means directly up and down. Don't forget that, students, okay? So when it says how far north is the plane from the airport, I know the airport's way over here. I get that. But what it's saying is how high, or not how high, sorry, how far north is the plane from the airport. So that's going to be this distance right here. And I hope that you see that, okay? I'm going to put N for north. And I know the airport's not right here where my pin is right here. I get that, but that's not the point. If I found this distance here, although I know it's 100, but if I didn't know it was 100 and I found this distance, that would be northwest, okay? When it says how far is the airplane, or how far north is the airplane from the airport, it's this line right here. And then look what it says. How far west is it from the airport? Well, that's going to be this line right here. So I'm going to put west. Students, cool. Look what I've got. I've got a right triangle. A right triangle that's missing two pieces. We know how to solve problems like that, don't we? See this right triangle right here? I'm going to go ahead and draw a right triangle over here to match it. I'm going to put 100 right here. I'm going to put a right angle right here. I'm going to put an N for north, a W for west. Oh, if I just knew one of the degrees. I do. How many degrees did you travel starting here? 300 degrees. So this is 90, 180, 270. You traveled 30 more degrees. So this angle right here inside your triangle is 30 degrees. So I'm going to put a 30 here. And now you're ready to find your two sides. This is really pretty simple, to be honest with you. So here we go. We know this is the angle I'm dealing with. So I go straight across. This is my opposite side. This is my hypotenuse. And this is my adjacent side. So what side do you want to find first? Let's find the north side first. So we don't want to use opposite and adjacent because that's two unknowns. I want to use opposite and hypotenuse. Now we should know the trig function that uses opposite and hypotenuse is sine. So I'm going to say the sine of 30 equals opposite, that's n, over hypotenuse, that's 100. Now multiply both sides by 100. 100 sine 30 degrees equal north. And now let's stop. You're ready to type this thing. Oh, by the way, what I did is I multiplied both sides by 100. Remember, when you have a trig equation and you're missing part of the fraction over here, you multiply both sides by the denominator. So I multiplied both sides by 100. Now, you're ready to grab your calculator and start typing things in. But guys, I want to remind you, anytime you're dealing with 30, 60, or 45 degrees, we have our special triangles, okay? And we need to be very careful and remember to use our special triangles. You should have these memorized by now. That's a 30, that's a 60, this is a 2, this is a 1, and this is square root of 3, okay? So, sine of 30, instead of typing that into your calculator, I should know sine of 30 by now. I should have that memorized. Sine of 30 is opposite over hypotenuse, 1/2. Opposite over hypotenuse. So the sine of 30 is 1/2. So now I have 100 times 1/2, which is 50. So I think we were dealing with miles in this problem. Yes, we were. So how far north is the airplane from the airport? 50 miles. 50 miles north. Now let's go ahead and find west. In fact, in order to find west, students, could I not just use Pythagorean's theorem? I mean, why not? Now I know this n right here is 50. And my w is a leg. So I'm going to say leg squared plus leg squared equals hypotenuse squared. Now, 50 times 50 is 2,500. 100 times 100 is 10,000. All right. Now I'm going to subtract 2,500 from both sides, and that should leave me with 7,500. Now, that's probably a perfect square, and I should probably have it memorized. Maybe it's not. But I'm going to go ahead and type it in real quick. It is not. Okay. I'm going to get 86.6. Or we'll just say 87. So there we go. 87 miles. So now you know exactly how many miles north the airplane is from the airport, and you know how many miles west it is. Students, did it not all come down to drawing this triangle correctly? And once you had this triangle drawn, then it's just pulling it off to the side and finding your two missing sides. Not too bad. All right. Let me grab a quick drink of water here. And let's go ahead and try another one. Okay. An airplane travels at 120 kilometers per hour for 2 hours in a direction of 319 degrees. At the end of this time, how far north of Chicago is the plane? Well, this is really not too bad here. Telephone's ringing. Let me pause the video. And okay, I am back. Now, here we go. So let's get a picture. Let's get a picture quickly of what this airplane is doing. There we go. There we go. And now it's traveling 319 degrees. So if I go to here, that's 270. And then I have to go 49 more degrees to get where the airplane is. There we go. So here's where the airplane started, here at the origin. And then here's where the airplane's at. Now let's make sure I know what the angle is inside this triangle. I traveled 90, 180, 270. So from 270 to 319, that's going to be 49 degrees. 49 degrees. So there. Now, in the last problem, let's go back a problem. In the last problem, they told us the plane traveled 100 miles. So we knew the length of this line right here was 100 miles. They've not told us that in this problem, but they have said the plane's traveling 120 kilometers per hour, and it's done this for how many hours? 2 hours. So if it's traveling 120 kilometers every hour, and it does that for 2 hours, it stands to reason the plane has traveled 240 kilometers. Right? I mean 120 kilometers for the first hour, 120 kilometers for the second hour, so I know the length of this line is 240. Now, at the end of this time, how far north of Chicago, this is Chicago Airport right here, Chicago O'Hare Airport, whatever, how far north is the airplane from Chicago? So I can drop this line down, and that's what I'm looking for, by the way, is north, and then I can always draw a dotted line here. I've got a right triangle again. It's like the last problem. And in this triangle, I'm only looking for just one side. All that they want me to find is the north side. And I know this is 240 kilometers, and I know this angle is 49 degrees. So we're all set, man. This is easy. Using this angle here, go across. This is your opposite side. This is your hypotenuse. This is your adjacent side. Now, you definitely don't want to use opposite and adjacent. That would be two unknowns. You want to use opposite because it says how far north is the plane, so we want to find north. So we use opposite and hypotenuse. It's just like the last problem. So the sine, the only difference is 49 degrees is not one of my special angles. So the sine of 49 degrees would be opposite n over hypotenuse 240. Now, in a trig equation, whenever you're missing one of the parts of the fraction, you multiply both sides by the bottom of the fraction. So we multiply the left side by 240, and we multiply the right side by 240, leaving us with n. So now we have 240 sine of 49. So grab your handy dandy calculators, make sure you're in degrees, and then type in 240, then hit the sine button, and then type in 49. Close the parentheses, hit enter, and you will get 181.1. So we'll just say 181 kilometers equals the distance north from the airport. 181 kilometers. Now in your homework tonight, I've only given you 2 homework problems for these word problems. Isn't that cool? Thanks, Mr. Earhart. You're welcome. One of the word problems will be like this here, where you find north and west or east, something like that. Maybe it's south, but either way, you get the point. You'll have a right triangle, and then one of these. All right? So 2 of those, and you're good to go. Now let's continue on and look at one more topic. And that's going to be central angles and arc lengths. Let me grab a quick drink of water. Central angles and arc lengths. And we're looking at lesson 5.4. Lesson 5.4, of course, the date, if you'd like to record the date, even though it feels like it's been 2 or 3 days. It is not. It's still the 26th, if you want to write that down. Central angles and arc lengths, lesson 5.4. You can see we're kind of going back and picking up some things that we needed to get to finish the chapter. All right, let's continue on. Now, due to time, I am not going to go into great detail about where this formula comes from. Although really, students, it's not that hard to understand, but we're not going to do that. Please write down this formula, and let's take a look at it for a couple of minutes. There's the formula. This is theta, by the way. Theta equals S over R. Usually I'm going to put a little line through my S's so they don't look like 5s. You do not need to do that unless you want to. Please write down this formula. Theta equals S over R. Now, theta stands for the central angle. And we will talk more about that later. R stands for the radius of the circle. And again, we'll talk about that later. S stands for the arc length. The arc length. Now, I know you're probably wondering what are we talking about? Radius, arc length, central angle. And I'll get to that in a second for you, okay? Please copy all this down. And once you have, let's look at just 3 problems, and then we're done with your notes today. And I've given you, I think, I'm not sure how many homework problems, maybe I told you 2 airplane word problems, and then about 9 of these. So not a lot of homework for tonight, okay? All right, here we go. By the way, I almost forgot. I'm so glad I typed these notes ahead of time. Oh, this is so important. This formula doesn't work. It doesn't? No, not unless your angle is in radians, not degrees. So if I give you a central angle measurement and I say 200 degrees, you better convert it over to radians, because if you put degrees into this formula, you will not get out the correct arc length and you will not get out the correct radius. So please keep that in mind. Okay, would you copy this problem down, draw a circle in your notes, and we're going to call this angle here theta. So we've got theta right there, all right? And notice the radius. Don't forget what a radius is. The radius, of course, is that line that starts in the center of the circle and goes to the edge of the circle. That's called your radius. Diameter is the line that goes all the way through the entire circle while going through the center of the circle also. So 2 is your radius. And then arc length. Now you're seeing what arc length is. An arc length is a length of a circle, it's a length on a circle. And you know the arc by, it can be cut off by lines like this. Like I've got a line hitting here and a line hitting here. So 4 is this little length right here. If I were to take that arc length and stretch it out so it was straight, it would be 4 centimeters, 4 inches, 4 feet, whatever. So that's what we're referring to when we say arc length. Okay, it's the length on a circle that's cut off by 2 lines like this. Now, in this problem here, I would like us to find the central angle. And this is so cool. Now, you could do this without the formula. You would have to find the circumference, okay, and then find out what part of 4 is in relationship to the entire circumference, and then take that part and multiply it times 360 degrees to get the part of 360 degrees that this angle is. Now, probably everything I just said didn't make any sense, but my point is this: there's a faster way to do it, and the faster way is this really cool formula that I just wrote incorrectly. Let me fix that. That we just learned. Theta equals arc length over radius. So I can find this angle in seconds. Cool. Are you ready? Arc length is S, so I put a 4 up top. Radius is 2, so I put a 2 here. 4 divided by 2 is 2. Oh, the answer for theta is 2 degrees. Go back a page. This formula only works when your angle's in radians. So that means this entire formula is always dealing with radians. So the answer is 2 radians. Now, what if I asked you to give your answer in degrees? You should know by now how to change or how to convert from radians to degrees. You always take your radians and you always multiply it, always, by 180 over pi, always. So do your multiplication. You'll get 360 degrees divided by pi, and grab your handy dandy calculator, type in 360 divided by, and then use your pi button, and you'll get 114.6. So theta is 2 radians, or 114.6 degrees. Now I know my angle doesn't look like 114 degrees. I didn't try to draw this picture to scale. I just simply threw it up there. Don't worry about that. You should always go by your data and information anyways, not the picture given to you. But nonetheless, there we go. We found a central angle by using this really cool, easy, neat formula. Now, think about this for a second. Could we not also find the radius or the arc length? Sure we can. So let's try these two problems and then look at the next page. We're done. All right, so we're almost finished. Hang in there. Now, let's take a look at a problem in which you have an arc length that's 8 inches. And by the way, if you want to draw a circle, feel free to. I have no problem with that. That's fine. And I'm going to go ahead and put this in red. So if you want to get a picture of it, don't worry about drawing it to scale. That's not a big deal. So you have an arc length that is 8. So here's your arc length out here, 8. You have a theta that's 40 degrees. Find your radius, r. Well, we can use our formula. Our formula is theta equals s over r. But hold it. Remember, you've always got to make sure your degrees or your angle, your central angle, is in radians. So let's really quickly, let's come over here where we have some space, and then we'll erase it later. Let's come over here and convert 40 degrees to radians. Do you remember how to do that? Anytime you're going from degrees to radians, you always multiply by pi over 180. So let's see. What would go into both of these numbers? 20, I guess? 20 would go into 40 2 times, and 20 would go into 180 9 times. So 2 times pi is 2 pi, and 1 times 9 is 9. So instead of putting 40 degrees inside this little angle here, I'm going to go ahead and put 2 pi over 9. So there's my theta, 2 pi over 9. So for theta right here, let me go ahead and erase this so we have some room later to deal with for the next problem. For theta right here, I'm going to put 2 pi over 9 equals, now, s is my arc length, that's 8. And then, of course, my radius would be r. Now, students, I hope that you remember this. I mean, this is kind of, boy, I don't want to lose you here, but, I mean, anytime two fractions are equal, I hope you learned this in middle school. Anytime two fractions are equal, you can do something called cross multiplying and setting your products equal. Let me show you what I mean. Anytime two fractions are equal, and these two fractions are equal, you can put an equal sign and you can cross multiply diagonally. So 9 times 8, put a 72 right here, and then cross multiply here. 2 pi times r would be 2 pi r. Hopefully you remember that from, that's pretty much middle school. Anytime two fractions are equal, you can cross multiply and set the products equal. Now we're trying to find the radius, right? R. So what's with the r that I want to get rid of? 2 pi. So I divide by 2 pi and I divide by 2 pi. Equals, these cancel, leaving you with r. And now with your calculator, type in 72 divided by 2 pi. You've got a pi button, so 72 divided by 2 pi, and you will get 113.1. So 113.1 inches is the length of the radius. So pretty cool. Okay, there we go. All right, let's try one more, and then we're done for the day. Here we're trying to find the arc length. Now again, if it helps you to draw a circle, please feel free to do that. I love that. I have no problem with that whatsoever. Let's see. I'm trying to think of some 180 over pi. That would be 139. Okay, I'm going to draw the central angle. I'm trying to draw it to scale as much as possible, even though I told you not to worry about it. I'm just trying to. So there we go. I'm getting a picture of it here. If you don't want to do that, you don't have to, but there we go. And now let's see. We have an arc length of x. That's what we're looking for. We have a radius of 4, and we have theta. Oh, it's already in radians. That's good. 3 pi over 5. There we go. So, using my formula, theta equals s over r. For theta, I'm going to put 3 pi over 5 equals, then for s, I'm going to put x, and for r, I'm going to substitute 4. Now remember what we learned over here, or what we reviewed over here. You should know this already. Whenever two fractions are equal, you can cross multiply and set their products equal. So I'm going to cross multiply 5 times x, and that would give me 5x. And then cross multiply here. 3 pi times 4 would be 12 pi. 12 pi. Now you're solving for x, so we're going to divide both sides by 5 to get x by itself. 5's cancel, and x equals 12 pi over 5. Now, if the book says to write your answer in terms of pi, then you're finished. If over here, the back of the book would have said, write your answer in terms of pi, then you would have left your answer 72 over 2 pi, okay? But then we went ahead and typed it in and got a decimal answer. Let's go ahead and do that here too. So here's your answer in terms of pi. Now let's type it into our calculators and get out a decimal. So I'm going to type in 12 pi with my pi button, so 12 pi, and then divided by 5 equals. And you should get 7.5. So I'm going to put an equal sign here and put 7.5. X equals both of these, depending how you want your answer written. If you want it in terms of pi, then here it is. If you want it written in decimal form, then here it is. I hope you've listened well. I hope you're enjoying the class. When you go to do your homework, there are students that do homework to just get it done, and there are students who do homework to learn something. And I hope that you're doing your homework to learn something. I really, really do. That's very important, okay? Do your homework. Check all the odds in the back of the book. If I've given you some evens, which I have, look, watch the video, watch those even answers in the video and check your answers. Then any one that you miss, go back and find your mistake on the video. Call me or email me if you have any questions.